All right, everyone. Um, Today, what we're going to do is continue on into some more kind of in-depth concepts that are really just a kind of a continuation of your curriculum. So there is a lot of this stuff that you have started on that you are going to be continuing on, that is methods and concepts that allow us to better work with data structures like arrays and objects. This is going to be a set of skills that is really, really frequently used. So in the past couple of classes, we have explored like getting information in like JSON format, like getting data from an API. And then that JSON format comes in as like an object to our JavaScript code. And then that code, that data structure can be in the form of an array or an object that has a array nested in it, or any sort of hierarchical list or object structure like that. Array object, list is another word for array. So it's very common that, you know, we have this raw data that's kind of in memory into in our program, but we need to be able to make changes to it, restructure it in some way, and those sorts of things. Also, there's a lot of sort of like interview problems and toy problems that kind of follow this pattern of like, hey, restructure this data structure, make this object into an array that looks like this, or make this array into an object that looks like this, something like that. So we're going to kind of go deeper into that whole world. So so I'm actually going to do this in the Node.js side. So that's not going to matter. If you feel more comfortable in the browser side and you want to follow along, do it in a browser. You could even pull up a terminal like this and just do it here. Firefox even has this thing where you can like pull out this little editor here, and it looks, you know, allows you to do like multiple lines and run it and all that kind of stuff. So you could even do it there. You could do it in a browser file, like an HTML file with a script tag, or you could do it like I'm doing it on the Node.js side. It doesn't matter. Find the JavaScript environment of your choice, and that's kind of where we'll be. So we'll be kind of in pure JavaScript today. Make sense? Is there any questions before we get started? Okay, so I'm going to cd dev cd OK coders, and then cd into our curriculum. I want to be in module 3, of course. Oops. And then I believe we're on day 7. But either way, I actually can just open up VS Code here. Cool. So that was what we last worked on with me. And then make sure we got the latest. We got the latest. And so yeah, JS deep dive NFP principles. I'm going to make a new file here. Just call it index.js. And then I'm going to say this because I'm going to open up my terminal and cd into module 3, day 7, and then node index modules. Cool. So we're set up where now we can like kind of get started here. So, okay, so the first thing that I want to point your attention to is that if you were to type in this concept, so in the README, there's this idea, what we call FP. What that stands for is functional programming, but don't worry about the concept of functional programming. What I want to point your attention to is that what a lot of people mean when they say functional programming is kind of what me and Zach will mean when we say functional programming, which is, so imagine that you had this array, okay? And imagine that it was, you know, just something like this. Well, then imagine that you wanted to like, say, get only the even numbers out of that array, okay? Then what would be kind of like your first thought to do?
My first thought would be a for loop.
That's what I would do too. Like first off, so for let I equal 0, I is less than r dot length, and then you know I plus plus. Which, for what it's worth, writing a for loop is always so tedious. Like I feel tired just writing it out. It's ridiculous. And then you can, console.log r I, right? And that's going to tell you the number, right? And then, you could say something like if ri divided by 2 is equal to 0. Sorry, not equal to 0. You're equal. Well, let's see. I was going to avoid doing this, but there's a little operator here we can use called modulo. So have you all been introduced to the idea of modulo before in JavaScript? Or modulo, whatever.
Yeah.
Yeah, okay, yeah. So we can just use modulo to like be able to do, you can see console.log. Let's just say an even number modulo 2. Oops. And if it's odd, then it'll have a remainder, right? So we could say if modulo 2, then right. Okay. So then we could do, if we wanted to get like const even r, we could say something like this, and then, even r dot push r I so should be all evens 2, 4, 6, 8. Okay. So like this is fine. This code works fine and it's great. But functional programming is this broad umbrella that you don't need to worry about at all. for a long time. And it's taken me several years to kind of like wrap my head around everything. But a couple of the key concepts that it allows us to do is it allows us to clean up our code and be a lot better JavaScript developers if we take on some of those concepts. And there's two that I really want you to kind of take away from today. And so I'm just going to type this. So however, two concepts make us better JS developers. One is clean functional code. So make our code clean using functions. And two is this fancy word, immutability. Don't mutate or change data structures. Copy them. Okay. There's a lot going on here that's like all under the hood stuff. And I highly, recommend if you're interested, going to further reading as to why immutable JavaScript is a good thing. And I'll show you one way how we can achieve this as well. So, and these kind of tie together when we talk about our main array-based functions. So there's three main functional array methods: map, filter, and reduce. You can do pretty much anything you want by doing a combination of map and filter and reduce. Okay. And it's going to end up looking a lot cleaner than writing this for loop. And it's going to allow us to be able to take like all of this code and a bunch of all this other messiness out of the equation. So without a functional approach. So get array of even numbers with just functional approach. And the way I would do that is I would say, okay, so we have all this up here, and just so that we don't cause any bugs, I'm just going to comment that out. I'll uncomment it here in a little bit, but especially before I push, but I'm just going to say R2 equals, and we'll just have the same thing here. So the next thing that we're going to do is do something very similar to this, but we're going to be able to combine all of this. So const even R equals R2. And if I wanted to, so we have these concepts: map, filter, reduce. If I wanted to get rid of some of these and clean up this array to make it only the members of the array that I want it to, which one of those, just guess, do you think I would use?
Filter.
That's right. So I'm going to do a filter here. And the filter method, if you open this up in this, it has what's called a predicate, but a predicate is just a callback. So it's a function that's going to get called, and it's going to get called on all of those members of that array. So this says a function that accepts up to 3 arguments. This is from the JavaScript, the actual JavaScript, like MDN, by the way. This is like in the source code. A function that accepts up to 3 arguments, the filter method calls the predicate function one time for each element in the array. It returns the elements of an array that meet the conditions specified in a callback function. Okay. So I know that I'm going to be able to do an arrow function. If I were to look again at this, this callback function here has the value, the index, and then a reference to the array that we're working on. So I almost always do something like element. Well, and I can just do element here because that's all I care about. If I wanted the index, I could get the index. If I wanted this array, then I could do that. But what I'm going to do is I'm going to just do element because that's the only one I need. I don't need to put the other ones if I'm not using them. And then I'm going to say, okay, so the element is a number. So element, and we'll just say we want it to pass the test. So maybe we just do the same thing, the same logic that we did here, and we say something like this. Oh. Cool. So it looks like we got the exact same result that we wanted here. And I did it in 2 lines. Does everyone kind of understand what's going on here? Is there any point of this that you would like to have clarity on? So a couple things to point out is when we're looping through an array, all we're doing is we're setting up a loop that we can use to then reference the array via the index. With the filter methods, with the functional methods, it already gives us that for us. So in other words, we don't have to access the array using the index. We can just get the element because it's given to us in the callback. We can get the index if we need it, but we don't need it in this case. It gives us the element already. The other thing that I want to point out is that we have seen array methods before that do not return anything. They in other words, you couldn't return it to a variable. In the case of map and filter introduce and a lot of the newer array methods that you see that are used very frequently, it does return a new array. And what I mean by a new array is if I were to console.log R2, the original is still the same. Okay. That is very different than, say, let's just do pop array JavaScript. So pop does actually return something. Like I could say, this, and what you're seeing here is you're seeing it originally had tomato as the very end. Pop takes the last element and it pops it off in the array. But 2 things happen. One is it returns this value. So it's returning this here, which is why it's logging it. It's not storing it in a variable, but it is logging it because it's being returned to the console.log. And then like in this instance, I'm doing the same thing and it's mutating it again by taking kale off, putting it in the value variable. And then now I have a value variable, which is kale, and a plants variable, which was originally 5 members. Now it's only 3. So see how it starts as 5, goes down to 4, then goes down to 3. It is mutating the original array. And this can be fine for a lot of use cases. But what we want to teach you is that when you have the ability to use a method that will not mutate the original data, then you should use it, and you should be able to, and it will actually keep you from creating bugs for yourself. It is very hard to debug code where data structures are being kind of passed all over the place and they're mutating. It is so much easier to debug and use code that has everything is just copies of one another. So let's see this used as an example here. Let's say that you want to do something like this. Let's say that you wanted to find cabbage, okay? Well, you could, go through here. You could say something like do plants, and let's just say if plants I and then I could do something like let found and then like found equals plants I, and actually I'll do this, I'll do the console.log after. So yeah, so we have something like this. Find a particular array element, find me cabbage. In this case, we're going to find it here. And let's see if that works. So found the cabbage, and it's going to be, found. So this is obviously similarly as this other example, the filter example is a lot of lines. And this can be for loop approach. Now we can do something very similarly if we do a dot pop approach, right? So like we can say something like plants 2, found 2, plants 2, plants 2. This may be confusing. I may want to do a different name, but just for the sake of argument here. Yeah, I knew that was going to happen. Where is it? It is going to be plants is not defined. Index.js is 25, so it's going to be here. So if y'all missed that, I just had an error because I didn't rename that variable properly. Let's see if I have another one. Still have something at 27. Cool. So now I'm back where I was. So with this approach, I'm going to do something like this. I'm going to do so we want to look through it. I will do a different type of loop. I'll do while plants2 dot length is greater than 0. I'm going to say let plant equals plants 2 dot pop. If plant equals cabbage, then break and we'll do found 2 equals plant, something like this. I could very well accidentally implement a infinite loop here, so I want to see. Nope, cool. So what I'm trying to show you is that like we have this approach and this works, okay? We have this approach, which works, okay? And this one does not mutate, but it's verbose. This one does mutate this original array, but is also verbose. There may be a different way that you can do that, like using a for each loop or something like that. But like because it takes one off of the end, eventually plants 2 becomes well, when it reaches cabbage, it breaks. But we could also have that. We could also take that break out only because eventually it's going to just not have anything to pop off of the array. So don't like this approach. We're mutating this original data, which is not great. And also it's still verbose. So let's see if we can use something else to make it even better. So I'm just going to we'll just do this with a dot find here. So we could do a dot filter, but I'll show you while we'll do a dot find. So the beauty of the pop is that it actually gives you the value here. Okay. But what happens with a filter is found for equals plants for dot filter plant cabbage. Is this cabbage? Okay, so what is my result here when using filter? So you can look at the code too. This is the code that I'm doing right now. And this is the result. Can someone describe to me what the result is?
An array with one index in it or one item.
That's right. So what do you think happened?
Plants or found for is storing the thing that it filtered out.
Almost. So what it's doing is it's saying what it does. If you were to look at the code of this, what it does is it makes a copy. The first thing it does is it makes a copy of this array. And then it will get rid of, it'll get rid of everything in that array. It may not make a copy. It may actually just make a new array. And then if it passes the test, it puts it in the new array. Does that make sense? But either way, the end result is it gives us back a new array, and that new array has one member, and that member is the string cabbage. Okay, now let's compare that to if we were to do a dot find, which is the most close relative to pop. It's not the exact same thing, but okay. So what are the differences between these two? Find gives us the actual element, whatever it is. It can be any primitive or data structure. Whereas this still gives us back a array. And so to access that, we'd have to do something like this to make it the same. Do you see why that's the case? Do you see that this is a array? So we have to access the array in order to get the actual data, the primitive of the data. Whereas with find, we go ahead and get the value itself. And for what it's worth, if I were to change found 3 to foobar, and then I were to console.log plans 3. Notice this obviously still says cabbage. My point is there's a lot of times in JavaScript where changing something like this will actually change it here in the data structure. And I'll show you how that can happen. So my point is that we now have this value. We don't have to access it via an array. So if we just want the single value, we can use something like find, and it will give us the thing that we're wanting. Okay. This is another way to actually be able to accomplish the same goal. Now, before we move into some other applications for this, I want to point something out. Let's say that I kept making changes to this right here. And I had it in multiple places, like I had it in here, I had it here. There's actually other places that I probably have it. I'm trying to think of how to ask this. What can I do to make my life a little bit simpler here, do you think? Anyone want to guess? Well, all this is a function, right? So what if I did something like, this could actually just go right here. And it would do the exact same thing for both of these. Do y'all see what I'm doing there?
Yes.
Cool. So the other beauty of the fact that this returns a new array is you can actually chain them together. You could effectively loop through this a bunch of times and be really, really explicit as to what you're doing every single time. which is a very, very different juxtaposition as like writing this code here and making this for loop a bajillion lines long, and it's really hard to debug and really hard to know what's going on. So this is the beauty of what we're calling functional programming. It's really just this idea that like you can do a bunch of stuff by chaining these together and manipulating these. And this is map, filter, and reduce. And also secondarily, there's honorable mentions. Find index, find and find index are two other ones that I use. Well, and then I also use for each instead of using a for loop. So I'm going to keep that in there, but those are just, this toolbox right here is going to be like most of what you need when working with data in the real world. I need to make this look nicer before I push it, but any questions before we move on? Okay,
So anytime we want, like, we would want to use a for loop, we should just try to use one of these methods instead.
that's your rule of thumb, yeah. I'll be completely honest, I don't write a whole lot of for loops. I don't write any for loops. I haven't written a for loop in a long time. Even if I did really truly need a for loop, you can use for each. It works a little differently. So like, instead of it returning an array like here, it will just look like this. It'll be like, I'll do what I did at the very beginning, but like, I'll just use plants for, but it has like, it has the element. And then this is all it does. This right here. So even if I do need a for loop, often I'll use this. And another beauty is that you can actually take this and put this in a function too, somewhere. But most of the time you do need to return something. And because you need to return something, like map, filter, or reduce are going to be your better bet. So that's the reason I say this for each is just an honorable mention. And like, I would just kind of like go into learning as you learn more, and especially as you go into like a real code base in the future. Just like know that you're going to use those as your first resort, and those are kind of like your tools. So this is a really good point. Just like anything else, you have a certain set of tools that you get used to using really well. My dad, he will use a screwdriver for almost anything. Like if he needs to pry open something, oftentimes he's getting a flathead screwdriver and maybe a hammer, maybe like a rubber hammer. There are specialized tools for everything. And if you were to go through each of these, there's a specialized tool for every use case. Similarly, if you were to go to a library that helps you with these, like Lodash has even more granular, more specialized methods for you to use on arrays. There's a couple of libraries that are really like this, but like, it's taking a second to load. But the point is that like there is a specialized tool for everything, just like there is in like real life. But use the, you can use your general tools for more things, and you can get really good at them. And so they become kind of like your go-to tools out of the box, right? And again, you can chain these together. So often you can get your end result by some combination of map and filter and reduce. Does that make sense?
Yeah, that's cool.
and it makes your code really clean. So it's all good stuff. So, okay. So if you go kind of take a step back there, I said that there are two main benefits to what we call functional programming. Make our code clean using functions. So we've kind of done that. And the other thing I mentioned is immutability. So in our .pop approach, we're mutating this, we're changing this original array, and it's the verbose version. So it's kind of like, we don't really like that so much. So the other big thing that we want to make sure to avoid is don't mutate or change, make copies. Okay. So imagine that you have a data set, it's from an API call, okay? And let's say that it was like some information about like a profile. In this case, it'll be mine. And yes, I'll give you my age. And then let's just say, and this will be in inches, so this will be 77 inches. So 6.5, yeah, on 6.5. So then let's say that you have a couple of functions that you want to send this data through. So let's say that you have some function. This is all going to be kind of like made up stuff, but like we'll just say like you know, we want to add increment age. So let's say that like I recently had a birthday or whatever. And then it takes some person object like the data that we have. And what we can do is we can say person object dot age equals or plus equals 1. And then we'll say return person object. So then we want to console, we'll do increment age data. That's a lot of data. Oops. Oops, I need to. So just so you guys know, oftentimes what I'll do is this will be all messy whenever we go through it in class, but then I'll clean it up really nicely and then push it. So I would encourage you whenever, like for me, I don't know how Zach does it, but for my classes, I would recommend like going back and revisiting like a couple days so that you can like refresh your memory and like let it sink in a little bit more. So I usually try to make this look even better and then push it up. So, okay, so what happened here?
Age went up.
That's right. So we incremented age. Well, if we had another function that was, say, like increment height, I don't know why you would have this, but you can imagine other
We
types of
definitely
data.
need that function, Devin.
What's up?
I was saying we definitely need that function.
Oh, I need to decrement height. I need to make myself shorter. minus equals 1. So I'm going to make myself shorter. Oh, I'm doing a string. I don't know why I'm doing a string. And then I need to actually do height there. So I'm making myself older, making myself shorter. So let's say that you had some function that was like, you know, some loop that was like, you know, for every year as someone gets older, I want to make sure that, you know, my person object represents them getting older. And I guess the thing that happens when you get older is your name stays the same usually, and your age goes up and your height goes down. So that's what's happening here. The thing that I want to point out though is that it's actually changing here in this object, right? So what's happening is this data object here, it is being defined with these values. And as it's going through here, it's changing this data on, like actually on here. Now, so this is all well and good because I'm using an example where it's like, okay, those are values that, you know, could change. Like I could legitimately get shorter, and I do legitimately get older. But like, let's say that, you know, let's say you had a function that was like, let's say that it was like reading some data from the person object. It was reading the name data. It was like, you know, reads the name data. And then like, let's say that you had a bug in which instead of doing a triple equals where you were saying, you know, John Doe here, that this was actually just equals. So instead of asking whether the name of the person object is John Doe, now what you're doing is you're doing what? I'm
You're
changing.
assigning the name to.
That's exactly right. So whenever I do something with the name, now what's happened is I have a completely different data object now. Now name is kind of a sort of not trivial, but it's something that is like it could legitimately reference someone else or something. But now we have this issue in which this object is changing. And imagine you're doing a for loop over a bunch of people, a bunch of person objects, and something like this happened, and you're like, oh, all of a sudden everyone's now John Doe, and then you save that to the database, and now you have this giant issue, right? Well, that's probably going to happen even if you weren't assigning it, but I want to show you that one of the things that you can do is that you can copy objects, and it's a good thing to copy objects. The best way to copy arrays, so the two main data structures, if you remember, are arrays and objects. To copy arrays, you can use map and filter and do. So we got that covered. We're good on that. Because what's happening, as I was explaining earlier, is that this is a brand new array. Anytime we're using this even array, that's a brand new array. So we have the original array preserved and the even array, we're good, okay? For objects, it's a little bit different. And what we just need to make sure of is that whenever we're doing stuff with them, that we actually copy them, okay? And so what I can actually do is I can, one thing that I'll show you too is that notice how I didn't even return anything out of here, okay? So if I wanted to, so in other words, what's happening is that this data is being passed in here and it's changing it, even if it's not returning it. So the point there being is that like a function doesn't have to return out or anything if it's being passed this reference here. if I want to, there's two different ways to copy, but I'll show you just the spread operator. So we'll just do something like, that's all you got to do to copy an object. You could do the same thing with an array. But that's all you got to do is use these three dots right next to it. So then what's going to happen is instead of mutating the person, I'm going to mutate the copy. Okay. And mutating a copy is okay. As long as we know what we're doing with that copy. You just have to be mindful of it. So if I were to do like this and call this, what's happened? I have incremented my age. I have decremented my height. But because I copied this original is still preserved. Now I can return the copy, and I think I know what's gonna. Oh yeah, so so I want to show you something that's really interesting. So this should be the person object returned here. Sorry, those are really, really long. I actually am a big fan of really descriptive variables, but that's fine. So instead of consoling data, we'll do this. And then name. So these are all coming from functions from the name. Okay. So what I want to point out is this really interesting thing. What is my height from the return of the increment age call?
$76. 76.
That's right. But have I called this yet at this point? What is the data coming into increment age? What is the value? It's 77, right? So by the time I have incremented my age, or by the time, so I've incremented my age, and by the time I console.log this, I've actually already also decremented the height. And I've done so also with the do something with name. So this is a really, really interesting type of bug that you might, it's not really a bug, it could be a bug, it very often is a bug. But the idea here is that each of these are going to return a reference to this original person object. Because it's still a reference to the original person object and not a copy, like in this case. By the time I actually console.log, I may expect to have, say, just a data object that increments my age. But what I actually have is I have it's all the same object. So therefore, any values that have been changed are going to be reflected in this console.log. Now, what I can do is I can say, well, what would the person object look like if I just did a copy? And what would the person object look like if I just did a copy for height also? So instead of actually wanting to see, like wanting to make these changes to the original data object, what if I just wanted to see what the object would look like if I did something like this? Well, what you would see is I would see that this Devin Mobley, his age went up, but his height did not. This Devin Mobley, his height went down, but his age remained the same. And this Devin Mobley, his name changed completely, but his height and his age also remain the same. And that's because now, whenever we get to these variables, you see, these are copies and therefore reflect only the data that happened, only the change that happened here, not the change that happened in all of these. Do you see how that could really simplify trying to troubleshoot a bug or trying to understand what's going on? We are trying to isolate and make sure that everything is can be broken down into its different parts. So in this case, we changed this from being from actually mutating these objects to now just copying them and seeing what the data looks like on the other side. That was a lot. Does it, what questions do you have about what was going on there? And does anyone have any questions on why it's important? Before
Sorry.
you said?
Yeah, because I'm a little bit confused.
Yeah, okay. So if I were to make these all return the original. So in other words, this takes some data object and it returns the same data object, but it also mutates it.
Okay, yeah.
Then what happens is, gosh dang it, sorry. Notice that the height and the age change. And actually, like, let me just really kind of hammer the point home. Like, if I were to just do something like this, now all of them are the same, even though I called them at different times. And I think even if I did something like this, you probably would still, it would look different. You would see it happen in sequence. But my point is that by the time we've reached the end of our program, these three things are all the same because we didn't copy them. Now, let me be clear, that may be fine in your program, but most of the time you don't want to change the original data. Most of the time you're saying, okay, you know, you're wanting to rearrange a copy of the data to work with it for a specific use case. Most of the time you're not wanting to actually make a change to this data. But in JavaScript, JavaScript allows you to. And in fact, this is going to be the most natural way to do it. What I'm trying to introduce to you right now is like immediately whenever I'm programming, if I have an object coming in as a variable like this, like I just had to train myself. Like it's kind of hard to like wrap your head around at first, but like I just had to train myself, like I'm just gonna make a copy. Or, you know, something like and what that's going to allow me to do is it's going to allow me to like make sure that I'm not accidentally changing this original data. I feel like, if I'm honest, I feel like this example doesn't like show you, say, like why it would be super bad in order to change it. But I guess from my perspective, it's kind of hard to like demonstrate that without you actually like having to go through and debug a problem where this is the case, which I think maybe we can come up with a bug that like that would be the case. I can tell you from experience that that is exactly what has happened to me. I remember spending about 4 hours on a bug where I was it was looping through a calendar. So it was looping through a series of days in order to like map out some instructions on each day of a calendar in a month. And every time it was like resetting at a certain spot into a completely different day. And I could not figure out why. What was happening is that my original data, I was using several functions in order to accomplish it. And my original like data object that was keeping track of the days, I was passing through it and making changes to it. So I never actually got to the end of the day. It kept resetting. And the only thing I had to do was something like this. I just had to make a copy. And it was a one-line fix, made a copy, and all that, 4 hours of headache was gone. I was able to fix my problem. There's computer science reasons why objects work this way. So again, this is like one of those things where like instructors have to just like tell you like, hey, trust me on this one. Like, be sure to make a copy with data structures. And the best way to make a copy is the spread operator with objects and then using map and filter and reduce. If you're using this, you're always safe because it's always making copy of the original array. So what I want to come back to and just kind of like reiterate, functional programming is this just this concept, and again, don't ignore your Google searches at this point. We just want to introduce you to a couple concepts. When you write functions, you want them to where you want those functions to not have to change any of the data. And whenever you're making code, you want to clean them up by using functions. We can use map and filter reduce, and then there's the spread operator for being able to make changes or to be able to copy objects within functions. What I'm going to do is I'm going to make this a little bit more simple and like make a better example out of this, and then I'll push it. So I'll let y'all know whenever that's done. But for now, I'm going to stop the recording and stop the sharing, and then we can, or I don't have to stop sharing, but if anyone has any questions and needs to stick around, feel free. But I know that we're over time, so anyone who's got to go, feel free to go.